The ancient concept of the flat Earth evolved from astrological and magical gods and natural powers to a static flat geocentrism, later mutating into spherical. It gave way to a heliocentrism that gradually also lost its static and centered character to evolve into the concept of infinite space, without confines, and full of stars that we call the universe. Once the obscurantist medieval period was finished, science was no longer afraid of being exterminated by the Inquisition, and was able to deepen knowledge about the universe. Isaac Newton and Gottfried Leibniz developed mathematics known as calculus. The reflecting telescope was perfected by Isaac Newton thanks to his work on the light scattering through prisms, which also started astronomical spectroscopy. The physical laws used for calculating orbits, trajectories, movements, and interactions of objects in the universe were formulated by Newton. Arthur and Sirius stars' light spectra were first described by William Herschel. The lines of the sun's spectrum were classified by Joseph von Fraunhofer. In an infinite and static universe, the night sky should be as bright as the surface of a star. This was the approach of Heinrich Albers, a matter that was called Albers Paradox. The change in frequency measured by the observer of a wave emitted by a source, when there is movement between both the observer and the source, was a phenomenon discovered by Christian Doppler, as he sought to determine the binary system stars' rotational velocities. He only had the light he received from those stars to measure those velocities. Hence, by spectrometry and with the precision of his time, he was able to observe red or blue shifts of the lines of his visible light spectrums. His observations and research allowed him to initiate mathematics, now known as the Doppler effect, to calculate the rotational velocities he sought. It's important to note that the search for Doppler never pursued to verify the expansion of the universe, a theory to be raised in the future. Each chemical element has a unique light spectrum line pattern, and Gustav Kirchhoff and Robert Bunsen studied, systematized, and classified the patterns of the elements at their fingertips. With these patterns they found some of these chemical elements not only in the solar atmosphere but also in the stars. Kirchhoff and Bunsen's work consolidated astronomical spectroscopy. The light spectrum redshift of the Sirius star observed by William Huggins allowed him to propose the hypothesis that, being the star's moving objects, its velocity could be calculated. Huggins, like Doppler, neither was trying to find anything like the expansion of the universe. Einstein published the special relativity theory. Redshift measurements on the light spectrum lines of 11 galaxies were presented by Vesto Slipher to the American Astronomical Society. Slipher was the first to propose that redshift would result from the apparent movement of galaxies from each other, due to a hypothetical interdistancing velocity, all interpreted through the Doppler effect. The general relativity theory was published by Einstein. In 1917 Einstein introduced what he called the cosmological constant into his original gravitational field equation, to force a static universe as a solution. It is speculated that Einstein stated that introducing that constant was the worst mistake of his career. In order to answer the question of whether the universe is static, expands or contracts, Alexander Friedmann used the newly released general relativity to derive equations that would give him the solution. If the universe were contracting, its objects would be approaching each other, occupying less and less volume of space, which would imply that they could be detected as a velocity of rapprochement, say, negative. Whereas if it were expanding, its objects would be moving away from each other, taking more and more volume from space, and the detectable distancing velocity would be positive. If the universe were static, that velocity would be zero. The variable velocity sign in the equations determines where the solution is going to. Friedmann was, first and foremost, a serious and rigorous scientist, and didn't commit the slightness of assuming a hypothetical expansion velocity of the universe, because not having sufficient and irrefutable evidence he doubted that such an expansion was happening. In an expanding universe there could be proportionality to the distance between galaxies and their interdistancing velocity. Based on this thesis, the priest Georges Lemaitre derived a value as a constant of that proportionality. Then, in 1931, he ventured the occurrence that the universe had originated from the explosion of a hilum or cosmic egg, a hypothesis he called the primeval atom, a precursor to the Big Bang. It is also his occurrence that cosmic rays are an evidence of the Big Bang. Then the cosmic microwave background had not yet been discovered. Lemaitre got rid of the awkward and inconvenient hypotheses of a static or contracting universe, and focused only on expansion, also interpreting by the Doppler effect a redshift of unknown origin, apparently caused by a hypothetical velocity of distancing. Such questionable rigor was probably based on Lemaitre's affinity both in Slipher's proposal and on the cosmogonic hypotheses of the astrophysicist Ernest Pasquier, supported also by Lemaitre's own religious vocation and formation. Undoubtedly, establishing the milestone of an explosion as the origin of the universe made it possible to justify that all of the previous was a divine act of creation. With due scientific rigor and a little more maturation, the simplistic approach to forcing that milestone could have been replaced by the simple argument that the universe, whatever its stage, would exist by divine grace. The hypotheses of the three possible stages of the universe, namely, static, expansive, or contractive, in the end are only boundary conditions to the equations, which produce families of solutions all mathematically correct, but all also with no practical meaning in nature, until finding the irrefutable evidence validating one of them against the other two. In any case, the hypothesis of expansion was about to face formidable and tenacious verified adversary facts and arguments, such as, among others, that the proportionality constant was never going to be constant or proportional. The far between galaxies, the faster they will appear to move away from each other, postulated the Hubble-Lemaitre law over the work of Milton Humason and Edwin Hubble. His works and the corresponding law confirmed Slipher's observations, from a decade earlier, and those of Lemaitre, 2 years earlier, on the existence of the redshift of the light of galaxies. But, according to the latest historical findings, Hubble, like many other astronomers and cosmologists, did not accept the apparent expansion of the universe performed by Slipher and Lemaitre, nor the linkage of redshift with radial escape velocity of the stars. His intransigence was not at all incompatible with the postulate of his law, by attributing the redshift to reasons other than the Doppler effect, even if he remained unclear about the cause of the redshift. Today we know that several different physical phenomena cause redshift. Hubble and Humason performed their work over the Mount Wilson reflector telescope, then the largest in the world, with a mirror just 2.54 meter in diameter, the size of a large dining table. Up to this point in the development of humanity, and until the future invention of the computer from the coming 1950s, all knowledge was treasured only on paper, by pencil, slide rule, trigonometric, logarithmic, and gas tables, etc. No radio or television, the aircrafts had hardly ceased to be of sticks, ropes, and rags, without calculators, computers, or internet, only with access to state-of-the-art knowledge through books in libraries of few universities or institutions, and with science always under the suspicion of the church. Generally galaxies and stars move in space, and that doesn't necessarily mean they're all moving away from each other. Calculus and mathematical analysis show that certain types of equations produce families or sets of solutions instead of a single one, all of them possible and mathematically correct, but most unlikely and without practical utility or meaning in nature. Doppler effect, redshift, special and general relativity. The longer the distance, the greater the redshift, but the increase is not constant, but apparently accelerated proportionally to distance. Several physical phenomena produce redshift. The cosmological constant, hammered into general relativity to force its solutions, then to a static universe and now to an accelerated expansive universe. A redshift being only caused by an imagined interdistancing velocity, based on the Doppler effect. The Big Bang, as an occurrence also derived from that apparent interdistancing velocity. Cosmic microwave background as alleged evidence of the Big Bang. The existence of magical energy and dark matter responsible for the apparent accelerated expansion of the universe. These last two aspects will be discussed in the next video. While it is true that science and its evolution should not be generalized in this regard, they have been managed in a more than questionable way. Mathematical sophistry such as dark energy, dark matter or cosmological constants, to name just three, have been systematically hammered into the models to force a la carte solutions.